try some different streaming setup. I'm using OBS. If I can find the streams online. Restream. Alright, so we're live there. Cool, we can see the screen. Let's go over to right. Hey, that's readable. Awesome. Sweet. Now, top left, that readable. Hey. That is readable. Awesome. Bottom left. Oh. Right. And my OBS setup. This is awesome. Full monitor. Crap. It doesn't. Awesome. And thank you, slide. Awesome. Alrighty. So, now that that's out of the way, just wanted to make sure that everything looks nice and polished. I've spent a little time in my lab getting my OBS set up so that I don't have the same problem I had on my last stream, where you guys couldn't see anything that I was looking at because it was all too blurry. So just thought I'd give an update on my current home lab setup. So currently I am adding some new hardware to the lab. This includes things these will be my new master nodes eventually. Right now I'm just working on getting some configuration and provisioning out of the way. So without further ado, let's go ahead and take a look at what I'm adding to the lab. And that's not the one I want. This is the one I want. Okay, so I am adding a bunch of Zotac CI320 NANDs. So these have modest specs. They've got an Intel Celeron Quad Core, roughly about 1.8 gigahertz, with the ability to have up to 8 gigs of RAM on a single SODIMM slot. They have one internal SATA 3 gigabits SSD via SATA interface. They don't have any M2 or mSATA, but they do have a flash card reader that I can use. And what I found after I bought them was that they have a SATA port, so I can add another hard drive to my nodes if I want to, which was kind of cool. They come with Wi-Fi and gigabit Ethernet. I bought these on eBay for about 165 bucks. I got 5 of them. That's kind of what they look like. They got USB 3 on them, and they're kind of a nice solution for running some master nodes. They're not too beefy. They're just kind of nice and small, so I can run 5 masters on them if I want to. So the first part on this is, since we've got the hardware review out of the way, let's go ahead and move over to how I'm provisioning these things. So I have over here I've got a playbook. I've got an inventory for the playbook. It's got a few things here. The first thing that I have here is I have 2 folders. One is an ISO folder, which basically just has a .gitignore file. And this is basically ignoring the output directories that my image for producing auto-installer ISOs uses to output the things that I need to deploy my machines. And then I've got this host images inventory. And this is going to have a few folders. One is it's going to have this inventories file. And this is basically what my system's going to use to uh, uh, provision all of my auto install ISOs for all 5 of these machines. So while I'm experimenting with this, I'm going to assign 2 of them to be workers and 3 of them to be control plane nodes. And I'm splitting these up into Zotac control plane and Zotac workers so that I can add an R610 workers category, because these are going to these 5 Zotac machines are eventually going to become my bare metal control plane, which is going to control my bare metal hardware in the lab. So um, that'll be things like working on. Sorry, I'm being pinged. Let's see here. Who's asking me a question? Ah, it looks like Mike. We gotta change that title. Yes, we do. Awesome. Maybe my oh yeah. Anyways, that'll be fun. Uh, not important for what we're working on right now though. So we're gonna continue. Alrighty. So, back to what I was saying. Yeah, so this inventory here is going to have the all of the bare metal machines in my lab. So eventually I'm going to add my 3 compute nodes for it back in the rack to this, and then I'll move these 2 back up to control plane. But while I'm testing out how I'm going to structure everything, I'm just using these as bare metal experimentation tools. From there, one of the things we do is we're going to set a few variables. We're going to set the ISO URL we're going to download. So this will download the 2004.5 live server ISO from Ubuntu and check it against the checksum. And then it'll drop it in a file locally on my drive. It will create an inventory date so that if I go and run this over and over again, and this is more important for when I'm actually building virtual machine images than it is for bare metal images, but it lets me create time-stamped virtual machine templates in my Proxmox servers, but it's not necessary for the bare metal. Adding my my public keys for the private SSH keys I'm going to have installed. Here I'm mapping my internal apt mirror so that all of the updates will go quickly. I have my user. It's looking up a randomly generated password for each node, and then it's giving a random salt for each node. So every time that you produce a new set of images with this process, you'll get a brand new set of passwords for every machine. And unique for every machine, because shared passwords are bad. You should use SSH keys. They are much more secure. I have 2 templates that I can use, one for BIOS and one for UEFI. These machines support a UEFI BIOS, so I'm going to leverage the UEFI template. And then I set my keyboard layouts and locale. In the control plane here, I'm adding the AutoD package, but I could add some more packages as well, and I probably will as I evolve this setup going forward. Again, with the workers, I can add specific packages as part of the install. And then for my Zotac machines, I've got a 256 gigabyte SSD installed, and so this is basically the partition mapping that I'm doing on that. So I'm creating a 100 gig partition, leaving 150 gigs for future expansion. And then I'm splitting off about 40 for the root partition, 5 for var, 15 for var log, 10 for var log audit, 5 for var temp, and 5 for home, and then the rest of the 100 gigs is being assigned to opt. And then for each of the hosts, I go through and I set up the net plan configuration. So here I am finding the interface by MAC address and renaming it to F0. And then I am going through and adding static addresses with my gateway address. So in this case, I'm giving it 10.5.50.10. It's on a /16 subnet. I'm assigning it to VLAN 61 and giving it a couple name servers and telling it to search the right ninja domain. So I do this for each of the nodes, and so that what will be nice is that this will automatically set up static IP addressing for all of the nodes as part of the boot up process. And as part of the installation process, it also automatically installs all of the security updates, which is why having a local app server saves you a lot of time on that. And then once all of that is done, then I just go and run my handy dandy Docker file here. So I make sure that I've got my lab automation directory set to the local path of this folder. Okay, so here I'm in my home lab repo infrastructure bare metal. Set my lab automation directory. Make sure that I've got my output directories created. And then I go here and run my Docker file. So a couple things about this. One is I'm mounting the output CI data and Ubuntu ISO directories to the output directories that the Ansible playbook in this image expects. I am mounting my inventories folder to the inventories folder on the image where Ansible's going to look for inventories. And then I'm overriding the group vars and the host vars with my local group vars and host vars. Setting the entry point for the Docker to the Ansible playbook, and then running my inventory, and I'm skipping the Packer and Proxmox upload tags because because this is going to be bare metal. I don't need to build a Packer template and upload my ISOs to Proxmox. So that's why I'm skipping those tags. And then I'm just running it on the playbook.yaml. And so what this will do after I run this is going to run a playbook in a Docker container. And we'll go over that playbook in a minute. But it's creating an extraction path. It's going and downloading the Ubuntu ISO. And when it does this, it's also going to check the files checksum. So if it finds the file there and finds the checksum, it'll evaluate the checksums together, and it won't download it a second time. So, but it takes a little while for that checksum to calculate. While that's downloading, I'll kind of explain the 3 different directories. The CI data directory is a temp directory that gets created for each of a temp directory for each host gets created, and this contains the CI data file that's used for the auto install. So this has things like what architectures your app configuration is going to use. We're going to end up deleting this file's going to end up deleting itself in a second. Username and password, host name, keyboard layout, networking configuration, SSH keys, storage configuration. So now what we're doing is we're extracting the Ubuntu ISO to this Ubuntu ISO folder. And so the reason why we're extracting this ISO is to allow us to alter the grub configuration so that it will automatically look for a CI data configuration. And so by default, when you configure it to run the auto install, it looks for another CD-ROM device that has a CI data volume label. And so this is kind of the trick that I use to make this really easy, so that I don't have to go in and type any type of configuration on the terminal. I just basically plug in a USB CD, DVD-ROM drive or USB device that I flash this ISO to with the installer, and then I flash the CI data ISO to another USB, plug them both in, turn the device on, make sure the BIOS is configured correctly, and then it basically runs unattended. And part of the reason that I went this route initially is that when I'm in an environment where I don't have a Pixie Boot server and haven't been able to set one up, it's difficult to do this in a remote automated fashion. So again, here what we're doing is we've extracted the ISO. We are inserting our preseed configuration modifications to the ISO Linux CFG and grubconf files, recalculating the MD5 checksum for the integrity validation, and replacing that in the grubconf. And then we're now building a custom Ubuntu ISO that we can then use for installing our Ubuntu installation in an automated manner or unattended manner. There's a little there. You still have to make sure your BIOS is configured correctly and all of that. But once your BIOS is configured correctly, then it basically just runs. And so this is great if you're trying to bootstrap a network and you don't have a Pixie Boot server yet. So one of the things that I want to explore as I go forward in my home lab explorations is can I run a Pixie Boot server on Kubernetes? And there's a couple of different projects that I might actually look at down the road. I had considered running a MAS server, but I just didn't want to go through the effort of setting it up and maintaining it in a highly available manner. So this is what we're doing. All right, now that we have the custom ISO created, it's going to create a checksum for that. And this is largely used for when I upload it to Proxmox for my virtual machines templates. So it makes it so that I don't have to worry about uploading it multiple times to Proxmox if I have created the same image. So while that calculates, we'll look at the output directory. What ends up getting output from the output directory here is we end up getting we get our original unmodified ISO. We have our custom ISO with its SHA-1 hash, and then we get a folder for each bare metal machine that we're creating an ISO for. Now, in that folder, you're going to get a CI data ISO, and this is the ISO that you'll use to configure the machine. You'll get a SHA-1 in case you need to upload it somewhere. You have an inventory date, which basically says when this image was produced. And then you have the randomly generated password for that specific machine. And as you'll look down here, you'll see that it does that for each of the 5 machines. So we finished writing the ISO checksum for the custom Ubuntu image. Now we're going to go through, and for each bare metal machine, we're going to generate a new password. We're cleaning up our CI data folder, cleaning up our output folder. And so we've got our CI data directories have been cleaned. We're creating them now. Creating the user data. terminal connection got disconnected. Still running though. Nothing like live demo complications. All right, so we've got our CI data folder generated. It created a new user data file. Let's see here, got our storage configuration. We have our packages configuration. Our output. So we've got our CI data ISO, SHA-1, our inventory date, and our new password for each of the machines. Oh, and then that is done. We now have all of our images produced. So that is produced basically custom CI data ISOs for each of my 5 machines. Hey, there we go. It's caught up. So this created custom CI data ISOs for each of the 5 machines, created unique passwords for each of the 5 machines, linked up all of my SSH credentials, set up all of my default packages that I want installed on every machine, and it will allow me to automatically have these machines update themselves as they go through the image process. So the next step would be to go and burn these images to media so that I could go plug them into machines and do that. But I have already done that in the background, and I will show off hardening them in another lab session. Let's go through the playbook that creates the image. That's not the book. Drop that bitrate to like 5500 or 6K. Try this. Is that better? Ah, got it. Okay. Cool. Alrighty. So, looking at the playbook, we have our group vars. So these are our default. All right. So here's our playbook. So this is the master playbook that I run in that Docker image. It's got the customized ISO, UEFI playbook, the CI data ISO, our Packer HCL generator, and our upload ISO playbook. So we skipped these 2 sections here because they aren't relevant to a bare metal lab. Let's just go through the 2 playbooks that we did end up executing. This is the customized ISO UEFI playbook. And so the first thing we do is we make sure that we've got our ISO URL, checksum, and name. We clean our extraction path. We extract the ISO. Well, we've created a directory to extract the ISO to. We create a download directory if it isn't already created. We download the Ubuntu ISO if we haven't done so already. We then attempt to extract the ISO using OSIROX, so OS Xerox. I guess that's how you pronounce that. So this extracts the Ubuntu ISO that we can then use to insert our pre-seed configuration. So here we're just setting the auto install server pre-seed configuration. We're telling it to use the hardware enablement kernel. We then add our pre-seed configuration to the grub CFG. And then we calculate the grub conf MD5 and replace it. And then we use XORISO to then create a new ISO file. And we get the checksum for that ISO file. We set that as a fact and write it to a file. And then once we've done that, we generate our CI data files. So that that will first clean the CI data directory. It'll make a new one. It'll then generate the automation user password. We have our ciphertext that gets created. So once we generated our password, we then run a quick hash on it so that we can put it into the CI data file because it requires it to be hashed in this way. We then write that into a user data template. We touch an empty metadata file because that's what the auto install requires. And then we build another CI data ISO using GenISO image. So this is what allows us to we make sure that it has this CI data volume ID, and that allows us to utilize a second USB stick with this image flashed to it to feed the auto install configuration using convention. We create a checksum in case we're going to upload it somewhere and write it to a file. This has been another episode of Platform9 Live. I am your host, Eston Rye, and I thank you for watching. This has been a lot of fun. Talk to you later.